Essentially, what you're going to need is a wrench, 2 flathead screwdrivers that are a little smaller, they're going to be used for prying later, a Phillips head screwdriver, pH 1 size ideally, optionally a tube of grease, rubber mallet, some epoxy. I like the faster stuff just so it has less time to drip and I can do it in multiple batches. Isopropyl alcohol for cleaning, 240 grit sandpaper, popsicle sticks, mixing cups, a ratchet strap, and I have this parallel jaw pliers. These guys are like under 15 bucks from Harbor Freight. It's the Doyle brand. I'll include in the description a link to that. And yeah, so what we want to do is we got to clamp onto this bell right here, and we want to clamp on really good. This one was extra tight, so that's why I had to bring ratchet strap in. Figured some of you guys might have it tight too. So the ratchet strap's having a death grip. You will scar your casing. Use some black fingernail polish if you want to clean it up, make it look closer new. We have it clamped down. This is the non-rotor side. This side here is where the rotor is, so we don't need to mess with this side. This is just off the bike. I have all the washers off of it and nuts on both sides. This last nut right here, it can stay. I'm not worried about it. Now, what we're going to do is we're either going to brace this against the table here and pull the motor towards us like that, or you can just tighten that back for demonstration purposes. We're going to flip it away from us. If you have an extra stubborn one, grab something hard like this wrench, slip it between the spokes, hold onto that frame, and we give this a nice few glove taps until it loosens up. This one was extra tight, so it needed option number 2. The first motor I did this to did not need all the fancy stuff. I didn't even need to use the ratchet strap. I actually had some Gorilla Tape on the jaws, so it's like it scuff stuff up. Still scuff stuff up, so I ended up just leaving it out. So now that we're here, what we're going to do is we're going to just twist it all the way off. I'm going to just leave the grip connected for now because it's going to make it easier and I'll have to then re-grip it when it's time to tighten. You want to get this nice and tight later. Keep loosening until it's all the way off. Flip it over. Guide your cable, that out of the way, out, and you're just going to start slipping this off. Okay. So now we've got our motor core here. We have our gears. Let's bring this a little closer for you. So we have our gears on this one side of the planetary. Don't unscrew these 3 screws here. Those guys are a pain. If you accidentally take apart your one-way bearing in here, just don't mess with that. And then we have these 6 screws along the perimeter. We're going to take these 6 head screws out, being very careful not to strip them, because they will be a pain if you do. 2 other things I forgot to mention we needed. We need Loctite, and we need paper towels, just to keep things clean. Now that we got the 6 bolts out from around here, what we're going to do is we're going to go get our flathead, pop in to this hole here, and we're going to start prying it up slightly. Then we're going to move to the next one, pry it up slightly. You're just going to work your way around until these 2 halves are separate. We want this stack to stay with this side over here, the top side. If it separates, you will need to undo these screws here to get more slack on the wires and work around it. We're trying to have this as assembly and keep the stator on there, and then your coils we want to stick on this side. So we're just going to work our way around, popping it up, just shoving it in and prying, going around. Some of the holes are smaller than others, so that I am using the thinner screwdriver for this. Now comes the fun part, because we're going to be fighting the magnet. I already started that one a little bit. So we're going on opposite sides, digging in with both of our screwdrivers. And we're going to fight in the strength, however strong this magnet is. I've not measured it. Our goal is to get this off without pinching our personal fingers. So I like to take it, rotate the screwdriver sideways so I get better leverage. Once you're under there, pry it up. This will probably take a few attempts. We're trying not to scratch up the coil, so just take it slow. Be careful. Just like that, pull it off. We got all of our magnets right along here, and those are going to be what we're going to epoxy. So now that we have access to our magnets, I'll show you the other side. Ideally, we did no damage to any of these windings, and these two halves stayed together so that we don't have to give it a little pop just to make sure mine wasn't fully together, to make sure we don't have to take apart this top and have extra steps. Now is the fun part. We need to get off all these magnets. This is a newer motor, so they did a better job epoxying it in than the old ones. And these magnets, they're shaped with a taper like this. So we want that taper to go right here. Let's look sideways for a better angle for you guys. So this is a bottom magnet, taper's going like that. Top magnet, taper's going this way. That way it locks into these grooves. So this is a newer motor that can be found on the later generation OG models, along with the OG2. You'll know which one you have based off the cable position. The newer, stronger motors have the cable come out of the side of your axle. The older ones have it come out the end of the axle. I don't know if they'll show up on camera, but these newer ones, they actually put a decent bit more epoxy around the edge. And if I try to pry it out, like it's not easily slipping out. Whereas on these older cores, this was one that got damaged. There's just about no epoxy holding it in. And whenever I give it a simple little pop, it usually comes up. Of course, if I find one magnet that actually still has some glue on it. So you just give it a little pop like that, breaks free, shoots out. On these ones, you'll want to fully remove the magnet, sand the back of it with the 240 grit, sand the inside spot, and spray it with isopropyl alcohol to give it a good wipe down. I would take all the magnets out, line them up on the table, and then put them back in. The old ones are also marked blue, red, blue, red, blue, red. The new ones, at least not on the side I have access to, are not marked blue and red. So for simplicity's sake, we're just going to create this nice layer around this that will hold it all together really well. If for some reason the epoxy you're using is too runny and it looks like it's going to get all over the place, you can add in this little glass bubbles. I'll add a link to them. This will thicken it up and allow you to then have it more the consistency of peanut butter or even thicker than that if you would like. Now that I gave you the explanation, I'm gonna start with an example on how to epoxy the old motors because they are in the most need, and the new motors, they're still recommended, but that's only if you're gonna be pushing a good bit above the shipped tune. That being said, there's manufacturing inconsistencies. Sometimes you'll have a motor that just dies. We're pushing these well past what they're designed to go. So hop in here. I'm gonna pry out one magnet right now just because I'm only doing one of them. Ideally, I don't want to turn up these little tabs like that. If that happens, just cut it. So if I take a look at the magnet, I'll see how these sides are slanted in this way, ever so slightly. I'm gonna focus on this back side here then. Going to give it a little spritz. And then I'm just gonna get that and rub that back end on some 240. Sandpaper, that is. You want to get it from shiny to scuffed. Should probably do a little bit more than that. If you want deeper grooves, you can go with like a 120. I'm fine with 240, so just to get a little extra surface area, ensure a clean surface. So I don't want the old epoxy on here. So there we go. This guy is looking a little rough. I'm gonna give another spritz and then a paper towel. Keep in mind, this will remove the blue and the red marks, identifying which magnet is which. If you're not careful, so ideally keep it off the ends or mark it some other way. Now we got scuffed magnet good. I'm gonna put that scuffed side up. I'm gonna go in to the channel where this is supposed to be, and I'm gonna give it a quick scuffing too. Try and get all the way down in there. Get the channel scuffed. Spritz of isopropyl alcohol and a nice wipe to just clean off all the junk. I'll set this aside for now. We're now going to take our epoxy right here. This is the steel reinforced. You don't need the steel reinforced, it just got to be a nice strong one. And I'm going to pay attention to which side is which so that whenever I put it back together I don't harden the holes. Dose a little bit out. We're going to mix the epoxy till it's a nice consistent color. I'm going to take this, I'm going to apply the majority of it towards the top lip. I'm okay if this is a little more runny on this part, but the other part I want to not be. I'm getting it in the groove, all around. Whenever the magnet gets pushed in, it's going to help spread that for me. So we're going down here, pushing in, pushing in. I can see it's spreading. Then I'm going to wipe the excess so they don't have all this buildup over here that can cause imbalance in the motor. And I'm going to get under that bottom edge too to ensure that we don't have issues there also. Push it in nice and flush. And there we go. We got that guy in. It's just going to dry up and it'll be good. If you want to do that on a new motor, you're welcome to, but I'll show you the bare minimum you need to do on a new motor. So now we're on to the newer style motors, or the state you get to once you have finished epoxying in all your other pieces. I'm going to take a paper towel, wet it well with some isopropyl alcohol, and give this guy a good clean. If I turn this drum counterclockwise, the inside magnet ring will also spin counterclockwise. If I turn it clockwise, notice how I'm able to stop it. It'll still spin, but you can stop with your fingers. So with that being said, if you spin this guy counterclockwise, nothing happens. But if I spin it clockwise, it stays. Just to help you with maneuvering this. So if I want to do some quick sanding or movements, I'm going to spin this outer drum right around like this, counterclockwise, so the inner one does also. And we want this guy to be nice, clean. Then I'm going to dry it off a little. Now I'm using belt sandpaper just because I like it. It's easier to get a better grip. I'm going to invert it. And I'm just going to quickly sand. What I have to do is apply pressure in one spot and twist it and the movement will get it to the other magnet. You just want to make sure that's evenly scuffed up throughout. So we take a look at this guy. That is an adequately scuffed motor in a good way. Now going to re-wet our ice with alcohol. It's about 100 degrees in here, so it's evaporating pretty fast. And rinse it off again. We're going to dry. Now that this guy is scuffed and dried. Okay, I got 2 popsicle stick pieces cut down. Since these are thinner ones, I'm going to want to stack them. This is to keep the epoxy off the areas we do not want it. And this time, so we're thicker, I'm going to be sticking in some of these glass bubbles. Just careful not to inhale these or have anything blowing near them. They are extremely fine powder and your lungs don't tend to like glass. So I'm going to do a slightly larger batch this time because I think I can get it all in one go. But ultimately, this is going to be a very light coat. And I'm going to put about equal parts of this powder in, just using a little popsicle guy to scoop it in. Okay, a little bit more than equal parts on that. Can always add more epoxy if needed. Stir slowly when you start mixing this stuff in. Okay, I got this guy mixed up nicely. It's a lot thicker. Got a bad angle for this, but hopefully you get a good one. Just gonna lather this on. Give it a spin to control. We don't want this to be a thick layer, but we want it in all of these gaps. And it's going to help hold on to it really well. I'm going to switch over to a popsicle stick that does not have this radius. I already cut one down like this, and that's going to just help us not get a bulge at the bottom. Get those other 2 popsicle sticks are keeping this ideally nice and neat. In reality, we'll see. I got it on most of it. We're starting to harden, so now's when you want to have a few popsicle sticks available, because once you start hardening, it's not much going back. And we're just trying to get all this unnecessary excess off and scraped evenly. If it goes wrong, wait for it to dry all the way and sand it down the rest of the way. You can always pull the motor core if needed, well, this magnet. And don't forget to get the popsicle sticks in the back out before it dries, or you'll have a fun time. It's not the prettiest hardening job on a motor, but it's got the cracks covered, it connects up everything. The dovetails have been extended all the way out as far as we can, and we don't have a ton of excess gloop anywhere. And no crazy high peaks. I'll hit it with sandpaper slightly once it's done, but I gotta wait for it to dry, and we don't have any drooping. So I'm gonna give that an hour to harden before we put together. Ideally you wait longer, but I'm making a video and I don't have all day. Dried a decent bit. I did a light sanding. It's in need of another coat. I'm gonna do a thinner coat, and that will help. And I'll get back to you once that's done, because I want to not have these shallow parts, and ideally a better consistency over the magnets. I don't want these high spots and low spots. I want it consistent. And there's plenty of space in the motor for where I can build this up another millimeter or half millimeter ideally without it rubbing And the last mixture, I put too many of the glass balls in, so we're going to go less of that. I did stick some of the glass bubbles in it, and it is looking good. We're having full coverage. Same thing as last time, just thinner. Glue is hardened. I gave it about an hour to the point where I can touch it. It's still a little soft, but not sticky at all. It's fine. We do want to leave this for 24 hours before actually riding it, just so it has time to fully harden. What we're going to do is, without pinching ourselves, because this will suck itself in, you want to compress this guy, your coils, to make sure it's fully seated. Then, we're going to take these two assemblies, and we're going to try and push them together without getting our fingers in the way, as straight as possible. And let's see if I can get this. We also want to make sure the bolt holes on these guys line up. It's going to be more difficult to turn afterwards. There we go, it just sucked it in. Straighten those holes up. Now, we want to get the bolts that we have, all 6 of them. I'm going to Loctite those guys real quick, and then we'll go through and tighten them. Okay, screws are Loctited. We're going to set them all roughly in place. First few threads to engage on each of them until, let me show you, we don't want it tight, but we want this guy here to come down and just touch the top, right like that. No tightening yet, because we are having to repress that bearing. So the screws need to put it in straight, or you will have all sorts of fun issues. Okay, now we got all of the bolts around here where they're down but not tight yet. We're going to tighten in a star pattern, so that way we can get all of them tight and work this down as evenly as possible. So we're going to do a few turns on first one, which I'll just say is the one where the cable comes out, jump to the other side to this one directly across where the cable faces, then over here, do, and then we'll jump back to this one, and then just keep that pattern going all the way around until they're actually tight. You'll feel once it starts to engage, give it about a rotation. So I just did the first lap around, and you can see we moved a good bit because there's a gap on this one. And if we look, there's a gap over here now too. And we're just gonna keep that pattern going, and you'll know when it's done. You can also count the little bands in between or measure that distance to make sure everything's straight and that it's fully seated. Okay, I just got all the bolts tightened. I'm gonna do a circular pattern around just to make sure that they're actually tight. We're just about done. So now that it's actually tight, if we want, we can add more grease on this motor. You don't have to. I like stuff being greasy, so I'm going to. Well, actually, first off, we can either use the adjustable wrench, or my preferred method is a 10 mil. And we're able to give this a spin, and everything should be spinning whenever you grab your axle. So see, we're now moving freely. Axle's doing what's it's supposed to. There we go, and then we freewheel whenever we go this way. There will be resistance, that's the magnets in the motor and the motor core and coils and all that stuff. You're actually generating power on the output if you spin it like that. So now that we've done that, I'm going to add extra grease because I can. I like to go a little bit crazy with this. Whenever just put it over the gears. Doesn't have to be over the entire thing, but I just want to get extra in here. How often do you open your motor to change its grease? In most cases, never. And then I also like to go around the housing here. You can see on this one, it looks like there might have been some rubbing, or that could have been them balancing it. I don't know, I don't really care. I just want to get some grease. Grease will help transfer heat, and it will, not as well as ferrofluid, but it will help. And it will just make sure the entire inside stays nice. I'm also going to throw a little dab of grease on the threads, just to help them glide along. You don't have to over grease the threads. I'm mainly putting it around the start of the threads and just going around. This just helps them in this next step. Next step is grab your motor, feed your cable through. Carefully slip it back together, making sure stuff is aligned. The motor cable can be a little bit annoying. You just gotta apply pressure, get it to slip out like that. We're gonna hop onto this top side and give it a spin, making sure that we're going on straight. Yep, right like that. That's my finger. Gap's closing, squishing out all the excess grease. And we are gonna give it a good tug to make sure it's tight. Don't want to smack it with a hammer because that would be crazy. Then we're going to free the ratchet strap. Grip. Spray with isopropyl alcohol to get the excess grease off. Keep that grease off your brake rotor. You will have it squeal. Leave it, and then we're going to give that a wipe and some nail polish. You can see on mine, I gummed it up pretty good because this one was on insanely tight. The first one of these motors I had to take apart was this one here. That one came apart. It was difficult, but it was way easier. No need for the mallet or any of the other craziness. This one here was a lot more stubborn. You can actually see how much gunking up I had on this guy. Not really much relative to the deep cuts on this one. So what you end up with is prone to vary from what I experienced. Hopefully you guys get one easier and closer to that. If not, ratchet strap and hammer. Slop job because it was done quick. Let's see if the camera decides to hide or accentuates my failures on it. But at least from afar, you wouldn't know it was tampered with. Last thing to do would be plug into the bike, give it a test run. Ensure that you are using the torque washers in the correct orientation or you risk busting your frame. Also, if you're going to be putting a ton of power through this, throw a torque arm on there. For those of you who don't know, torque arms, this nifty little guy here, uses a hose clamp and 2 pieces of laser cut metal, and it just goes over your axle. You'll want the 12 millimeter, not the 14 millimeter, and it gives it something else to bite onto so it doesn't destroy your frame. And then you just hose clamp this section to your frame, so that way you get this nice leverage for the motor to grip onto instead of the aluminum of the frame, and then just this little tongue of your torque washer, allowing it to actually put the power to the pavement. That's one of the reasons why the controller mods ship with speed as a priority, not acceleration, not torque, because I'm not trying to wreck your bikes, and I don't want you guys to wreck your bikes. If you want to go ahead and put more power, there's going to be options for that, and I will make videos on how to tune it for that. But you need to make sure your bike's capable of it. I'm shipping these controllers to be capable of great speeds with a stock bike. Now, once you do this, you can put even more power to it. You can get more speed, you can get more acceleration. Go with the torque arm, get the power. Even then, you can push the power too far and still bust your motor on this. This is still built to be a 300 watt motor. It still has the heat dissipation capabilities of a 300 watt motor. Now, your shell here is not going to get that hot. I've done crazy pulls for 15-mile rides where I get up 35 miles an hour. I was averaging about 25 miles an hour on one of this motor here actually. Completely fine. Casing doesn't even get hot, but the inside is. And there is not temperature capabilities on the controller for this generation. And that is something that I'm looking into for future generations, but we're not there yet. If you have any questions, please let us know. Remember, this is entirely on you, your risk, your reward. And if you have issues taking this back apart, you can do it to fix high points. If you get a little internal rubbing, which whenever you spin it, you would feel that hit. You're going to have resistance when you spin it, but you'll feel a inside the motor. And that's whenever you want to go take it back apart, find your high spot, sand it down, and then you should be good. Or if you just fry your motor, you need a new motor. Go switch to a direct drive one or get another stock motor. I will say though, if you move to direct drive, you will not be able to use the controller without recalibrating it for that motor. And if you want to learn how to do that, search some videos on how to program a VESC. That's all it is. It's a VESC controller. Use the VESC software. I'll have some videos on how to do basic tuning. We'll see if I make a video on how to actually program it from scratch for those of you who are running direct drive motors. Have a great day. Have some